Good to see everybody. Many familiar names and faces. And honored to be here. We're in an interesting position. Like many people know the work of our team when we were within EHTD, developing the Epic tool. Uh, in a couple of ways, like the life of those projects sort of grew maybe too big and too different to fit within an architecture firm. And we're now spun out and as an independent entity. That's the thing called C.Scale, which I understand that many people that know Epic might not have tracked that. And it's really exciting today to talk about what that transition looks like for the tool and the tools that we're building, and really the way that we're moving into the kind of wider world of understanding and mitigating whole life carbon emissions from buildings. So I'll share my screen there. Um, So there's like a kind of apocryphal story that I've heard a couple times in the world of software, because for better or worse, that's the direction we're headed, where sort of a user, of a software like goes and gets a job at an engineering company at some big tech firm, fixes the bug that annoyed them as a user, and then quits the job and moves on with their life. That's obviously not quite what we're doing, but really like trying to approach our practice as people developing tools from the perspective of practitioners, trying to solve problems that we faced in our practice at EHTD. In the way we're trying to solve these problems with LCA tooling, we're also taking seriously that the tools that we build are one part of a larger kind of LCA ecosystem. In building an ecosystem, there's lots of components, and we see accessible, easy to use tools that help scale practice being one of many components that all can support each other in building out both a more robust background data ecosystem all the way forward to the things that allow us to set science-based targets for the building sector at municipal, regional, national, and international scales. In this like practice that we're developing and this new set of efforts, there's a couple sort of like watchwords that we try to kind of bring into this to sort of help level set our approach to this industry and the software we're building. The first thing really is just moving with the understanding that there's no such thing as perfect data. Each data source is good for some things and inappropriate for others, but really what data needs to be meaningful and what the data you add to projects helps to build is context on the projects, context of the data in the way it relates to supply chains, etc. So how do you make this context apparent, obvious, and useful in the design workflow? The second thing that we're really cognizant of is that there's no perfect tool. And as we continue to build C.Scale into a wider and wider platform, our goal is not to build a walled garden. It's to build interoperable tooling so that the work happening to develop Tally 2.0 that Václav will talk about and the work that we're doing can really be complementary, trying to contribute to not just creating a platform that lives in isolation, but really supporting workflows at firms, which will always, traverse kind of a landscape of tools and platforms. And finally, both in the way that we build the tools, internally, trying to really highlight sharing and collaboration features to help people work together. Every project is a team sport. And when we look at communities of practice like the CLF and the Seattle Hub, we see that also being true across the kind of like network of folks interested in whole building LCA and whole life carbon. So how do we structure these collaborations in the platforms that we use to do the LCA? So if that's context setting sort of about the spin out and who we are and what we're going to go do. The other thing that's very timely to mention right now is that DDX reporting season is upon us. One kind of, we'll say, like nice thing, not being in an architecture firm anymore, is that I don't have to worry about this reporting this week. But we're also really worried about it because we want to, or thinking about it because we want to support all of our users in doing the same. There's been a lot of really exciting work that the AIA 2030 Working Group has done to expand embodied carbon and LCA reporting in the DDX, either reporting simplified embodied carbon metrics as part of the standard upload, or a new and more detailed reporting pathway where you can report emissions by life cycle stage and by project scope. So I'd encourage DDX signatory firms, AIA 2030 commitment signatory firms who are on this call or representatives of those firms to really try to pursue and test these pathways, because we see this as a really essential part of getting these data reported and harmonized across the North American building sector. Okay, so I'm going to back up and talk a little bit about things we're doing at C.Scale, to talk about some of the data behind it, the way we're trying to make things accessible, and then I think I'll have some time to do a really brief demo of the new version of the tool. So we're really planning some pretty top to bottom changes in the way the tool is built and designed, focusing on the UI UX improvements to make the tool useful and delightful, all the way down to rebuilding methodologies and data sets on the back end, focusing on sharing and collaboration features. There's a lot of workflow problems that people are encountering. We posit that much of what makes LCA sort of difficult in practice is solving many small problems. What is the density of this material? What spec section do I reference? And trying to really focus on solving those and moving that forward into interoperability and expanded data, blah, blah, blah. Just trying to build context around what we're doing as we make this transition. And I don't mean for this to sound sales pitchy, but just to help fill out like the transition that we're sort of building toward. The way we think we're going to sort of start to build this into the tool, one of the early things we're working on is automated scenario generation. So previously, when people are setting up early phase scenarios in Epic, you have to model every scenario. This new set of features allows users to automatically enter a tool with a set of auto-generated scenarios. So I'm going to turn my video off because I think the video is making it lag just a little bit. So that you can get right into modeling with operational, embodied, and whole life carbon reductions right in the tool. Again, trying to just help users with relatively less experience doing this modeling see results more quickly. And we're going to build this out from just sort of some common scenarios to retrofit specific scenarios to assist in retrofit planning, firm specific scenarios, and then build out some optimization algorithms to help find carbon and cost optimal scenarios as well. Another thing that we're really excited about is enabling more granular data editing in the low resolution tool as it exists. Supporting early design is important, and moving that forward into schematic design even more so. So allowing users to input custom data where it's available because they've modeled an assembly, they've modeled a structure, helps bridge those gaps and ensure that the results that are coming through in our tools, are connected to the rest of the data that the firm is referencing in their workflows. Something else that is live in the tool now that we're really excited about is we're now sort of surfacing structural and material quantity intensity data. When the CLF benchmark, the V2 report comes out soon, there's going to be some material use intensity metrics there, because in addition to targeting low carbon materials, we also need to be understanding how our design decisions contribute to materially efficient buildings. So, making this data available in the free version of the tool helps drive decisions around material efficiency, and we hope helps build sort of fluency across the industry in the way that these SMQI or MUI, structural material carbon, quantity intensity, I should say, or material use intensity metrics are interpreted. Back to the theme of the DDX, there's a lot, I think, riding in the next couple of years on really getting this right. And one of the things that has made it harder to get this reporting done is having the staff at all levels of experience and seniority who are often doing the uploads, trying to interpret LCA results and get them entered into the DDX reporting platform. We're releasing, hopefully in the next week or two, a set of PDF generation features that enable designers to automatically crosswalk the work that they've done in C.Scale to the reporting that they need for the 2030 commitment, to enable streamlining of that process of just getting this data input in the correct way with the right numbers in the right fields. So that's sort of an announcement of like who we are, why we're doing this thing, and sort of the things we're working on short term. Again, all these capabilities that I talked about so far are free to use in the application. And I have about 5 minutes left, maybe 5 or to 7 before I pass it off to Václav. So I always think that the best thing to do to talk about tooling is to try to use it live. So I'm going to click over and we can try to build out a project. We've really done a total kind of interface redesign of the tool. So when you log on, again, free to create an account and do all the modeling, you get end up on this project page. And I'm going to really focus in this session on retrofit modeling because it's something that we've worked hard in the last 6 months to do a better job supporting. So I'm going to create a new project. We'll call it a Seattle retrofit. We'll call it Seattle office retrofit. Maybe so we have a use type. Maybe we'll call it a school, so it's a little more interesting. Here I am nitpicking the wrong fields. Say the project's substantially complete in 2027. It's in USA. And actually, can somebody in the chat give me a postal code in Seattle? I don't actually know.
98101.
Thank you. 98101. All right, awesome. So it's a school building called a K-12 school. Say it's 3 floors and the total constructed above ground floor area maybe is 80,000 square feet. I'm going to unclick auto generate decarbonization scenarios so that we start with a blank slate. And it'll create first a business as usual scenario. There's a business as usual new building. And we think it's important to have when you're considering retrofits, this as a reference point. But it's not the only reference point, that's meaningful. So I'll create a new scenario and I'll call this retain existing so you can understand what it means to retain the existing building. And I'll go to these reuse parameters that we highlight at the top of the left-hand side and just start moving these over. Say we're going to retain 100% of all the existing assemblies. Say we don't do anything. There's obviously still then energy use that happens in the building. You can see most of it's from fossil fuel use. And we can talk about that some too. And then, replace the materials over time. But maybe like the scope that's currently being modeled isn't exactly the scope, of analysis that is covered in this project. So you can always go to all project settings and tune the scope. Say I'm going to remove refrigerants in site work. Maybe they're for some reason out of my operational control. That's great. It tells us that over the life of this building, with the grid as clean it is in Seattle, and if I think, well, what if the grid's going to get, this is maybe an ambitious model of the grid, we can choose a scenario that has a slower decarbonization potential. And actually, even in that case, we still see that the majority of emissions in every year come from fossil fuels. So now I can start to, compare right away these scenarios, the business as usual new build versus retaining existing building. But maybe actually I think business as usual in Seattle for a new build will be a little different. So I'm going to edit the baseline here. And when I'm editing the baseline, it gives a warning because we're changing the basis of comparison against other scenarios. And actually the baseline's more likely an all electric building. And maybe like, if it was a new building, it might be possible to achieve, say, an EUI of something like 45. And now we start seeing this trade-off happening around 2050, where the business as usual new building, if it's all electric on a greening grid, it starts to look better from a whole life carbon perspective than the retrofit. But I think we can do a better retrofit too. So I'm going to duplicate this retain existing building and start to sketch out what a better retrofit is going to look like. So I'll rename this to DER for sort of deep energy retrofit. But I guess that could also be confused with distributed energy resources. So I'll say deep E retrofit. And with this scenario, let's start to tune these assumptions. Now, I'm just going to move some sliders, but obviously when this conversation happens, it usually happens in conversation with engineers. And say we're going to replace some glazing, replace a bit of the opaque envelope, maybe replace some of the roof. There's definitely an interiors refresh that's part of this project, right? And, a major service upgrade. And then with that service upgrade, I can start again, like here's a deep energy retrofit. Say in this retrofit, work to electrify the building. And we think in conversations with, engineers, we can get the EY down to something like 25. And then maybe I make sure that I'm not just doing a retrofit, but I'm doing a good retrofit. So I'll look at these and see what my major contributors are. And I see that this is true for many retrofit scenarios, that interiors end up taking a relatively larger, part of the whole life emissions picture in retrofits. We include those by default. Often they're excluded. But really, this tells us immediately that just thinking about core and shell emissions might get you most of the way there with a new build, but ignoring interiors and services and retrofit projects, you're ignoring a large chunk of the emissions pie. So there's some CLF baselines that we use here that we sort of like have untangled and done some bottom-up modeling for interior finishes, interior construction, and F&E, so that we can understand differences in interiors carbon intensity by use type. And we roll them into these sort of simple to understand 20th, 50th, and 80th percentile metrics. So we'll go to best practices. 15 years maybe is a reasonable replacement period for schools. And that tells me that when I move forward in design and I'm really like in a tool like Tally, when I'm looking at my interior construction, okay, my overall kind of per floor area, goal is to achieve something like 9 kg CO2e per square foot if my project's going to stay aligned with this sort of goal set. And I also, say I modeled out some envelope upgrades, maybe for my transparent enclosure. I'll say it's something like the 50th percentile of available enclosures in terms of carbon intensity. And again, there's great benchmarks published by AirUp and some stuff by Payette that help understand what these numbers are and what they should mean for use in goal setting as you move into design. And now we can start to compare these scenarios, and you see a really clear pattern. That's true in Seattle. I think it's true a lot of places, but it varies so much based on how green the grid is, based on, we'll say, like local carbon intensity. Something like concrete varies a lot regionally. Where the deep energy retrofit pays back its carbon very quickly in just a few years, better than a business as usual, even a net zero new building or this retrofit. And you can also look at those same metrics, right? In other ways. I think, and this is where I'm going to risk maybe breaking it. I'm going to try to move this project to a different grid. I'll move it to, if I'll move it to DC, which is on PJM East, we see a pretty different trade-off between these emissions profiles as, yeah, there's a totally different electricity grid that it's attached to. So trade-offs happen in different years and in different ways. Again, because this regional grid information is really important for modeling out which retrofit scenario is going to be most impactful. So that's just a preview of the way you can use the tool to model differences between retrofits and new builds, or just different sort of scenarios, new building. Again, free to use, and I hope people on this call have a chance to use it and try it to go out and do some preliminary modeling before they move forward into tools like EC3 and Tally, which I guess I can pass it off to Václav now to continue the conversation.